Hello everyone, it's the Gossip Guy here, and you're in for a treat. Thanks to the Hashgraph community up in Vancouver, Canada, we were able to get a hold of some footage from the recent meetup on May 30th that featured Paul Madsen from Swirlds, or Hedera Hashgraph. So, with all that said, let's dive into the presentation.
So my name is Murdoch, and my day job is an insurance advisor. I help people access powerful and unique coverage to receive a tax-free cash benefit if they get sick or injured. That's my day job. And I'm also a Hashgraph Ambassador. Before we dive into things here, I want to take a moment to acknowledge WeWork, and specifically Brooke for helping us out. Brooke's been obviously helping us out with setting things up. So come on up here. Give us a few words, tell us what WeWork does and the value you guys bring.
Thank you. Hello everyone, welcome. Apologies for the technical difficulties, but we had to play the hockey game. So. Cool, so welcome to WeWork. For those of you that don't know, we're a shared office space. So we have your typical co-working all the way to private offices, kind of ranging in size from 1 person all the way to 27 person. This is our first location here in Vancouver, but we have about 275 locations worldwide. And we'll have a second location opening July 1st, and then a third opening September 1st here in Vancouver.
Thank you, Brooke. Really appreciate your help through this. Very grateful. This is pretty awesome to start things off in a venue like this. So I'm going to start things off with just for a few moments before I turn the floor over to Mr. Paul Madsen here. We're very lucky, very fortunate to have him in town all the way from Ottawa to get the ball rolling on the Hashgraph conversation. So my story started actually a few months ago. As you know, I'm a financial professional, and I was on the phone a few months ago speaking to another financial professional about talking about what the world is going to look like in a few years' time. We were talking about exponential technologies like AI, 3D printing, driverless cars, and of course the conversation drifted along towards distributed ledger technology. And that's when he said, "Andrew, have you heard of this thing called Hashgraph?" And I said, "No, what's that?" So he pointed me towards a YouTube video, and I started down the rabbit hole. At first I was skeptical. I thought, okay, here we go, another one of those things. Then very quickly realized this is something different. The capabilities that Hashgraph boasts is something like I've never seen before. I quickly realized that the impact this technology will have on my industry, the financial industry, and other industries out there, make it so that I need to pay attention to this. I want to be a part of the conversation. One thing led to another, and I became a Hashgraph Ambassador. So that's kind of a little bit of my background there. What is Hashgraph? Hashgraph is a next generation distributed ledger technology. What they've solved here is, I'm trying to stay out of the light here too. What they've solved here is some of those issues that blockchain is facing regarding scalability, security, and performance. And how do they do this? Dr. Lehman Barrett, he's an incredible guy, and I know Paul's going to share more about him in a second. He's an incredible guy. He actually achieved the fastest PhD in computer sciences at Carnegie Mellon. He did it in 2 years and 9 months. He's been working on this problem. He's one of those guys that just walks around for hours on end solving math problems in his head. And this was one of those problems that he's been working on. He started in 2012, and for the past 6 years, he's been trying to solve this issue, and he developed this algorithm that allows you to achieve consensus on a distributed ledger technology with keeping those 3 things in mind: scalability, security, and performance. They can do basically all the things that blockchain and Ethereum can do, plus a whole lot more. They closed a $3 million seed round with New Enterprise Associates, one of the world's largest venture capital firms, and they actually beat out IBM's Hyperledger for the credit union space. Right now, they've already been deployed in over 6,000 credit unions. And they came out, okay, so back in September, they went to an event called Stealth in San Francisco, where it was a hackathon. And they did 2 pretty cool things there. One, they actually, developers created a distributed fair eBay. But what I think is more impressive is they created a state of emergency protocol that solved the clogging and congestion problems of cell phone systems during an emergency crisis. Okay, this is the thing that caught my attention. I have a background in emergency services. I was a firefighter. I was a Canadian Coast Guard rescue diver at the Hashgraph base. And I'm proud to say that I truly believe this technology has capabilities to save lives moving forward once we get to the stage where these things are actually being accessed and used to their full capabilities. This is where it really got my attention. So Hashgraph has gone viral. Journalists all around the world have picked up this story. We've got over 35,000 people in our Telegram right now. And in December, they did a roadshow through Asia where meetups like this are popping up all over the place on a global scale. And I'm proud to say that Vancouver is finally on the map. And now we're a part of the conversation too, right? So thanks for being a part of this journey. Yeah, Vancouver. And so with that, I want to turn things over to Mr. Paul Madsen. You're here to see him, not me. And I'll just give a little background on Paul. He actually has a background on identification management. He works on with Mance Harmon, and Mance is actually one of the founders of Hashgraph as well. And today, Paul is the technical lead of Swirlds, based out of Ottawa, and he is lucky enough to, we are lucky enough to hear him speak with us today in Vancouver. So welcome, Paul. You should be okay.
That should be okay?
Yeah.
Yeah. Good? Good?
Everybody can hear you, right?
Thank you very much, Andrew. I think I am lucky. I've spent 2 days in this beautiful weather. This is awesome. So I'm Paul Madsen. I'm from Swirlds. Swirlds is the company that created Hashgraph and is taking Hashgraph to the market. But I'm here to talk about Hashgraph, the technology, and Hedera.
You want the mic? Yeah, let's do the mic.
We need a mic. Our plans for.
Sorry about that.
So Hashgraph is the technology. Hedera is our public ledger, our nascent public ledger. So it's kind of an incestuous, complicated relationship. Hopefully I'll clarify that. So we're a consensus algorithm. Blockchain is a consensus algorithm. Hyperledger is a consensus algorithm. What does that mean? Coming in from the airport yesterday, walking from the SkyTrain, I saw this BC Power sign. This was perfect, right? Because this is what consensus is meant to mitigate. It's meant to mitigate the abuse of power, right? Because consensus is designed to allow people to come to agreement on something, on business transactions that are happening amongst themselves, critically agree on the order, the timing and order of those transactions, but critically do so without somebody in the middle mediating all those transactions and having inappropriate influence and power, right? We are trying to disintermediate the third parties, the trusted third parties that historically have been the default mechanism by which people who don't necessarily trust each other nevertheless want to be able to do business with each other. And that's the challenge, right? We want to be able to come to agreement, come to consensus on when transactions are happening, because that's the first step. Once you can agree on when something has happened, you can ask yourself if it's valid, should it have happened. And do so, depending on the deployment, you have to expect that some of the participants in the network will be malicious. They'll be Byzantine in the terminology, and will act explicitly to harm you and help themselves. So you have to expect that some of the participants will be unreliable. And critically, the network itself may not be reliable, right? We know the reality of networks. Some messages may not get through. So that's the challenge. How do we come to consensus presented in the likelihood of these two faults? So I draw the analogy between consensus models, different mechanisms by which we attempt to address that challenge, with democracies. There are two high-level models for democracy in the world. I think 98% of societies follow the representative model, where citizens like you and I elect leaders. We elect prime ministers or presidents, whatever you call them, premiers, and we empower them with this special ability and permission and right to make laws. And the social contract is, you make the laws, we'll respect them. If we don't like them, we'll vote you out. But for the period of their term, those politicians are specially powered. They have the ability to make laws where others don't. Contrast that with a direct democratic model, and I think Switzerland is the only first world nation that does this with any regularity. California as a state is notable for doing so, where citizens like you and I, of course, they elect politicians as well, but they also have the ability to directly influence laws that they will be subsequently governed by through referenda or plebiscites. So it's a much more granular democratic model. Rather than electing someone and saying, you decide, we'll decide together. Consensus models can fall into those two categories. Historically, say the last 9-10 years, it has been the representative model of democracy as manifested in blockchain, whether proof of work based like Bitcoin or leader-based models like Hyperledger, et cetera, that have been the default choice. There are direct democratic models for consensus, and they haven't been viable because of their inefficiencies. But both models historically have had issues. So as in democracies, in a consensus model, if you are empowering one node, even for a short period of time, with this special ability to decide what consensus should be, what the law is, well then you can be vulnerable to that leader being compromised or bribed or taken down through a distributed denial of service. You can mitigate some of those risks, but fundamentally if you pick one node or miner or staker or delegate or whatever you choose to call them and say, for the next 10 minutes or for the next 17 seconds or for the next month, you are special, then you risk that specialness being a vulnerability emerging. So there are issues with leader-based consensus. On the other hand, that direct democratic model, when applied to consensus, hasn't scaled well. Historically, it hasn't been viable because it's manifested in a voting model where, in a community, if you want to decide on some proposition, the order of two events, historically, the voting models, the direct models, have manifested in ballots flowing across the network. So I might cast a vote that says A happened before B. Somebody else says B happened before A. We tally those up. We talk about the fact that we've just tallied them up. We issue receipts to each other about the fact that we just tallied them up, and so on and so on. So it has not been an efficient mechanism for consensus because of all those messages that have had to flow. That's my segue to Hashgraph, because Hashgraph is a consensus model that gives you the same sort of intuitive features of that direct egalitarian model of democracy, where there are no leaders, where we don't empower prime ministers or politicians or miners for even a short period of time with this special power. Instead, we work it out amongst ourselves. We collaboratively determine what consensus should be. But critically, we do so without the inefficiencies and the bandwidth waste that historical voting models have been vulnerable to. That's the value proposition of Hashgraph, that we have the attractive features of that direct democratic model of consensus, but do so at speed. So notably, we are not a blockchain. If you think about a blockchain, by definition, blocks of transactions that are cryptographically bound through hashing to older blocks of transactions, so a linear model. By definition, one block has one parent, the previous block in history. In a DAG, a given block or event, we call them event, or it could be a transaction in some models, can have multiple parents. So rather than there being a single hash that connects a block of transactions to older events or transactions, there's two, or potentially more. So in some sense, it's a trivial distinction, but it has significant consequences in how you establish consensus. Because ultimately, a blockchain spends all its energy trying to force transactions and to some extent shove them into this relatively constrained linear historical model. And proof of work, as a notable mechanism when applied to blockchain, is really just trying to make sense of history so that we can shove it into that historical model and prune off alternative histories. We're not the only DAG. Lots of other ledgers, I think, are recognizing the flexibility that a DAG provides relative to linear chains. We're not the first DAG that's come to market. So IOTA, Tangle, Nano, Byteball. I think we often get compared to those DAGs because our diagrams look similar, right? When you look at our white paper, we have a DAG, it looks like Tangle's DAG, et cetera. But I think more critical or more fundamental than whether a given ledger is DAG-based or otherwise is what does the DAG represent? If you think about a DAG, it's a data structure with nodes and edges. What do those edges represent? What are the relationships that you're capturing in that data structure? Our data structure is notably different than the other DAG-based ledgers, and so the consensus that we can extract from that DAG is very different as well. But I think what is true of all DAGs is a kind of a high-level distinction between how a DAG-based ledger works and how a chain-based ledger works. As I said, in a chain, all your energy is spent on pruning off blocks, orphan blocks, or alternative versions of history so that we can constrain and force everything into a consensus definition of the order of blocks. And as I said, proof of work is one mechanism by which you ensure that at most one or two candidate blocks exist at any one time, right? And it's all about forcing transactions into that linear order. And once you've done so, once you put all that work, quote unquote, into doing so, consensus is the chain. That is the thing you've tried to agree on. In a DAG, you don't spend all your energy from the start pruning off transactions. You're more flexible. You're more forgiving of alternative temporary histories. You let those alternative histories build up. You build an arguably richer data structure, the DAG, in our case the Hashgraph, and then you retroactively go back and analyze that data structure. So the data structure itself is not consensus. It's not the chain that we all agree upon. We agree upon it, but it's not the end goal. The end goal is the consensus that you extract from that shared data structure. And so that has significant consequences because the DAG itself is a temporary mechanism, a means to an end. It's not the end in and of itself. So for us, our DAG, our Hashgraph, the thing that we are going to assemble is a history of messages. It's a rather mundane semantic, right? We're going to talk amongst each other. I'll explain how we do so. We are going to independently build up the same representation of what everybody else knows about a set of transactions. We're going to build up the same representation independently so that when we subsequently analyze that data structure, we're going to come to the same conclusion about the order of the events within that data structure. So it's the fact that our DAG captures temporal messages that have actually flowed across the network that is fundamental. Other ledgers use the same idea, right? We rely on gossip as the means of communicating those messages. Bitcoin uses gossip as well to communicate transactions out to the miners, and then for the miners to then subsequently send the blocks back to the community. For us, the times at which those messages are sent is fundamental, and we record it. In other ledgers, it's just immaterial, because they don't emphasize the temporal aspect of those messages. But it's because we emphasize that and record it that ultimately we are able to deliver a consensus order in a faster manner. I'll stop there. Questions? So as I said, gossip for us is just a messaging model. If I'm a node in the network, logically comparable to a Bitcoin node or an Ethereum client, I learn of something happening. Maybe it's me sending Andrew 5 coins. I want to communicate that fact to the rest of the network. I'm going to do so by gossiping. And gossip just means I pick one of you in the room randomly, and I tell you the news that I'm trying to send Andrew 5 coins. You do the same to somebody else. You effectively pass the news on my behalf. I do the same. So in a group this size, probably in 4 hops, all of you know that I'm trying to send Andrew 5 coins. That's the first step. We all know about it. It happens relatively quickly. It's resilient to any one of you leaving the room or collapsing. So we're resilient to any one of you being taken offline, because if one of you goes down, the gossip just flows around you. And it goes out fast. It's an efficient way to get the news out. So at this point, what gossip has given to us is a mechanism by which you all know that I'm sending Andrew 5 coins. But that's not the goal. The goal is for us to all to be able to agree on a time to assign that transaction. That's what we have to get to. The next step in enabling that will be to add to the actual messages by which we gossip additional information. So the reality is that if I gossip that news out, you're all going to hear about it at different times, right? Just given the fact that one of you is going to be the last to hear of the news, one of you will be the first. So maybe there's 2 or 3 seconds difference in the times that you all hear about this transaction for that very first time. And there'll be different times. So how do we get from that fact that you've all heard about this at a different time to a shared agreement on what is the best time to represent the group consensus? How do we get to consensus when you all have different representations of when that thing happened? Well, we add, as I said, a small bit of extra information to every message. When I pick Tony and I say, Tony, I'm trying to send Andrew 5 coins, and Tony sends it to somebody else, he adds the fact that Paul told him that Paul is trying to send Andrew 5 coins. And he does so through a hash. Like, he captures that relationship, that history, that message in a hash that he adds to his block. And then he gossips it out as normal. Everybody does that. Whenever you talk to someone, whenever you gossip about a transaction, you add a hash that logically says, and this is how I heard about it. So the news spreads out, but what the gossip does is it allows everybody, by analyzing that data structure as represented by those hashes, to build up the same history of when you all learned about me sending Andrew 5 coins. So we're getting close, because right now, 3 or 4 hops of gossip, by us adding those gossip hashes, that representation of the last message, we all have the same history of messages. We don't yet have consensus on what time to assign that message. That's the next step. But at least we have a shared data representation that we can now analyze and ask questions of. So, you know, this is our DAG. It looks like IOTA's Tangle. As I said, that's why we get compared. For us, our event, somewhat similar to a block in that there's a payload. These are the business things. These are the currency spends, the file uploads, smart contracts. These are the things that we're trying to come to consensus on. And those are all within a signed structure with 2 hashes. One hash points to the last event that the creator of this event received. So that arrow in that diagram is the magic, because it's by analyzing those edges that everybody is able to calculate in a consistent manner the history of when everybody else learned of a given event and the transactions within. So we all now agree on a history of messaging of a given event and the transactions within. And so I can look at my hash graph, my local copy of that data structure, and I can calculate when any one of you in the room first learned of me sending Andrew 5 coins, just by looking through that data structure and looking at the hashes and the relationships captured within. And I can do that for everybody in the room. So I can put all those times in a list, in an ordered list from earliest to latest. And we're going to say that the consensus timestamp is just the median in that list. And I can perform that calculation, and you can perform the calculation, and we all come to the same answer. Because we all come to the same conclusion about who should be in the list. We all calculate the median the same, and we all calculate, therefore, consensus agreement on when me sending Andrew 5 coins happened. That's it, right? We've been able to independently come to an agreement on when we should say that me sending 5 coins to Andrew happened. But critically, if we tried to account for everybody in the room, the full community, then if one of you left the room, you could shut us down because you weren't there to gossip. So your entry in that list would be empty, and we'd be vulnerable to any one of you either accidentally or maliciously going offline. So we have to pick from the full community a subset that is appropriately resilient to any one of you faulting or maliciously trying to stop consensus. And we do so by voting. Again, it's a function, it's a calculation that we all do locally by looking at our hash graph, analyzing it independently, and independently coming to an agreement on which of the 25 of us in this room should be allowed to contribute a time to that list from which we calculate the median. Again, we do so independently, we don't talk about it, but we came to the same conclusion as to who should be in the list. And it's a virtual vote because we don't cast ballots over the network. We just make that calculation locally by looking at our own local hash graph. It's because it's virtual that we don't have the inefficiencies that I talked about before of those historical voting models. This is just a calculation we do locally. So, the end result of which is that we all agreed on who should be able to contribute a time to that list for me sending 5 coins. We all agreed on the times within that list. We therefore all agreed on the median of that list. And we therefore all agreed on the consensus timestamp for that transaction. We're done. That was the goal, right? We move on. We do the same operation for the next transaction that is flowed amongst the network. We're constantly, iteratively performing that calculation of building up the hash graph, looking at it, voting, determining a consensus timestamp, moving on. So that's how Hashgraph works. Any questions before I talk about the features of the consensus? Hashgraph as being fast, fair, and secure. So we're fast relative to other ledgers because we're efficient. So if you think about the theoretical minimum in efficiency in both bandwidth and processing, like just getting the news out about my 5-coin transaction took up some bandwidth between us as a network, right? And there was some processing involved. So there's this theoretical minimum in bandwidth and processing. There's no consensus. We haven't yet achieved consensus on it, but at least everybody knows about it. And that used up some bandwidth and some processing. Hashgraph runs pretty close to that theoretical minimum, because with respect to bandwidth, all we added were those hashes to the messages. So there's a certain amount of bandwidth required just to get the fact of me sending 5 coins out and any other transactions. We add only 1% or less, it can be less, in those additional hashes relative to that theoretical minimum bandwidth. So we're very efficient in bandwidth. Contrast that with those voting models where there were all those additional messages. So not drawn to scale. We're also efficient in processing, particularly when you contrast us with proof of work, right? Proof of work is by design explicitly inefficient. That's how it works, right? It's designed to slow things down so that we can prune off blocks and keep this consistent order. Because we're efficient, we're fast in terms of throughput, in terms of transactions per second. So these are some curves from the white paper that we announced in March. So they're curves because for us, throughput is not a number. It's a relationship, it's a pattern between the achievable throughput, how many transactions per second we can deliver consensus on, and a corresponding latency. And there's an inverse relationship. And both of those things depend upon, critically, how many nodes there are in the network and how far away those nodes are, how geographically distributed. So these curves refer to different numbers of nodes ranging from 4 to 128. In this case, distributed across the US. So that line represents 128 nodes, some on the east coast of the US, some on the west coast, some in the middle, and so forth. You can see that with those parameters, 128 nodes, we can deliver throughput on the order of 300,000, 400,000 transactions per second. Notably, though, as throughput goes up, so does latency. So if throughput is your goal, then there's a corresponding price to pay and a latency of approximately 11 seconds. If latency is your goal, then you can tune your network accordingly. But that's the sort of ballpark numbers we can deliver for consensus, ranging from 50,000 to 500,000 in a single shard. So we haven't yet talked about sharding as a means to achieve greater scale, but just within a single community, a single set of nodes, that's the sort of scale we can achieve throughput. I think you're all aware of the sort of scale that Bitcoin and Ethereum can currently provide on a public ledger. They have plans and architectures that are designed to enhance that. And there are other public ledgers that are coming out with numbers perhaps in the 5,000 transactions per second. The caveat is that those consensus transactions are just determining consensus. So any real-world transaction, consensus is the first step. You agree on when a transaction happened. Typically, you have to validate the signature of the sender. If I'm sending Andrew 5 coins, everybody has to determine if it's indeed Paul signing the transaction with his private key that is authoritative over that wallet. So there's a signature verification check. And then ultimately, you have to actually process the transaction. You have to do an input-output. You have to increment one wallet, decrement the other. So those 500,000, or in that ballpark I described on the previous slide, that was just consensus. Any real-world transaction will involve these 3 steps. To reassure ourselves that these other steps were not going to be bottlenecks, we partnered with one of the major chip manufacturers, and they wrote us a library that allowed us to use their GPU to do the signature verification check. And we were able to demonstrate over 1 million transactions per second using that GPU. Similarly, we don't have yet numbers for this step, but we don't think that is going to be a bottleneck either. Net is that consensus is expected to be the slowest piece, and our consensus is fast. So we think that the sequence of events will be fast as well. So fairness for us refers to the fact that our ledger does not empower any one node, miner, staker, delegate, et cetera, block producer, at any one time and give them this special power to decree what consensus will be for the next block, 10 minutes or whatever it is. Because there's no leader in Hashgraph. In the scenario, the analogy I used, there was no one of us in the room that was special with respect to determining what the consensus timestamp for that transaction should be. So nobody in the room had special ability or influence to skew that timestamp or prevent it from being recorded or slow it down in some sense and give it an unfair timestamp. So we're fair in that sense, in that the timestamp that we collaboratively and egalitarianly come up with is just in some sense, because it's not influenced by any one party. So we're also secure. One aspect of security is that, again, because there's no leader, we don't have that vulnerability to a DDoS. You can't take down one of us and prevent consensus, because consensus just flows around. But a more noteworthy aspect of our security is the fact that we are Byzantine fault tolerant. In this context, BFT means that the consensus that we deliver is final. It has finality. There is a moment in time when everybody in the room came to the conclusion as to the time to give to that transaction of me sending Andrew 5 coins. Everybody came to that conclusion at different times, but there's a moment in time when everybody came to it. And once you came to that conclusion, there's no going back. There's no possibility of having to anticipate that that will be revoked. That's final consensus. So it's a step function in certainty. There's a moment in time when I'm completely uncertain as to what the time is, and then there's a moment in time when I'm absolutely certain of the consensus, and I move on. I take the next one. Contrast that with the sort of probabilistic confidence that a blockchain delivers you, where as you add blocks, five or six blocks, sort of the best practice to reassure yourself that a given block will not be rolled back. You have this probabilistic guarantee or confidence that a given transaction in a given block is good, but there's always a small but finite possibility that you might make that miscalculation. So it's a different sort of consensus. And the asynchronous, the A in ABFT, means that we can deliver this sense of consensus, this final consensus, in an asynchronous network, one that is realistic, where messages take different times to get across the network. We don't have to make assumptions about how long it takes messages to flow across the network. So ABFT is sort of the gold standard of security for a consensus ledger. And we think we are unique in delivering that relative to others. And because we have these, what we think are a unique combination of fast, fair, secure, we think we can address use cases that are either not viable with alternative technologies or haven't yet been practical given the scaling limitations of first-gen blockchain. So a cache that works, right? That doesn't take an hour for settlement, for which the fees are not more than the value of the coffee you're trying to purchase. Because we're efficient, we think we can enable super cheap micropayments and enable IoT use cases where a sensor might be sending up data to the ledger and paying fees of a thousandth of a cent as opposed to $2 or $3 for a Bitcoin operation. And because we're fair, we think we can enable a category of use cases that we would suggest are not practical within a blockchain where there is a miner or a delegate. Any use case where there is some aspect of matching, bids being going out, or some scarce resource that people are competing to bid on and win. If there's a leader in that model, then they have undue influence, and they can skew the fair matching of an auction or a game or a market. So that's Hashgraph, how it works and how it's different, we think. Hedera is our relatively nascent strategy and plans for a public ledger built on Hashgraph. So Hashgraph is just a protocol. We started our business selling Hashgraph into enterprises, so a permissioned networks of credit unions or supply chain. We demonstrated that the technology works, but the vision has always been, the full vision has always been a public ledger built on the technology. And Hedera is our platform by which we'll take Hashgraph to the public ledger. So we would argue that a public ledger needs these 4 characteristics. We've talked about performance, hundreds of thousands of transactions per second at seconds of latency. We've talked about security, resilience to DDoS, ABFT, fairness. Governance and security, or governance and stability, those are trivial in a permissioned network of 6,000 credit unions or 30 supply chain partners. But in a public ledger, those are challenging. And we will address these through means and mechanisms that are different than the other public ledgers. The first notable difference is that our governance model is one that's inspired by Visa 50, 60 years ago. Visa, the charge payment processing system, was created by a man named D. Hawk. And so we've taken our inspiration from that model. And governance will be assigned to 39 global blue chip companies. So it's a different model. The responsibility of managing how this ledger evolves, making decisions about fees, making decisions about the evolution, the roadmap of features on the ledger, that will be taken by 39 companies, a mix of verticals, a mix of regions, chosen both because they are brand names with reputations that hopefully will engender trust to the mainstream and so help adoption, but critically, because they have a reputation, the assumption is that they will act in the best interests of that reputation as they manage that network. Term limited, So some will be in for 2 years, some will be in for 3 years, and then it'll be voted out and somebody else will new come in. The motivation there is that when part of this council, this governance council, a large bank or a large auto manufacturer, the decisions they make while part of the governing council will then be that which they need to respect and apply by when they are no longer part of the council. So the hope is that this tension, this competitive tension, this distribution across time, region, and verticals will limit the possibility and potential for collusion amongst these 39. So it's a different model, right? This is very different than Bitcoin's somewhat anarchistic governance. It's very different than Ethereum's governance model. I do think the other emerging platforms, EOS, Cardano, et cetera, Definity, are moving towards this, recognize the importance of a more mature and stable governance model. But it's a different model. And for some, you know, it's too different. It's sort of anathema that you could imagine entrusting a public ledger to 39 corporations when the whole proposition here was to disintermediate corporations. So we would argue, and I'll argue, that when we think about centralization, we should think about what we're trying to prevent and along which axis we're trying to prevent it. So here's a graph that argues that one axis of centralization is that of consensus itself. How does the protocol work? Is the protocol itself centralized? So Bitcoin, the premise of Bitcoin is that the protocol itself, proof of work, is highly decentralized. That's the theory. Ethereum similarly. The other aspect, the other angle or axis, is the governance model that determines how that ledger should evolve. Again, in theory, these are both very decentralized. You know, Hyperledger, Swirlds, up here, permissioned consensus, so only a defined set of people can contribute to consensus, and by definition, a permissioned governance model. Hedera positions herself up in this corner, a completely open consensus model. There are no nodes. Anybody can join as we evolve to scale. But it's a permission governance model. Now, for some, the fact that we position ourselves up here is incompatible with the fact that we claim to be fully open here. I would argue that all ledgers face a pressure up to the top right. It's almost like nature abhors a vacuum of decentralization, and there's this push. So while Bitcoin and Ethereum, this is the premise and theory, in practice, we've seen centralization in miners, we've seen centralization in the core dev team, we've seen centralization and inefficiencies in governments, in forks and splits, both in Ethereum and Bitcoin. So the theory is bottom left corner. In practice, and in reality, to date, all ledgers have felt this pressure to the top right corner. We think we will be more resistant, more decentralized by staking out that corner and building in mechanisms to prevent a slide to the right than if we were to naively try to position ourselves down here and wave our hands and ignore the reality of that push. So this is the other context of public ledgers. This presumably is not even the full list of Bitcoin clones, right? There's 1,700 altcoins. multiple Ethereums, multiple coins. This is the reality of open source in crypto, right? Open source is an incredibly powerful software development model that historically has allowed communities to align their interests behind a single common code base and push and evolve that code base. As soon as you throw in the potential for financial gain by forking and splitting and cloning and creating a new coin that is 99% identical but for some parameter, well, then this is the reality. This is the consequence of open source, full open source in crypto. We don't want that because we see the negative effect that's had on the network effect of the original Bitcoin, right? The vitriol that goes on between Bitcoin Core and Cash is not healthy for the community as a whole, nor for either of those two coins. So our licensing model is one that leverages the fact that Swirlds has a patent, or patents, US patents on Hashgraph itself. And we'll use those patents to enforce, as necessary, a licensing model that is designed to prevent the sorts of clones and forks that we saw in Bitcoin and we see to other extent in any other coin. So we don't want to see a Hedera or a Diet Hedera. Pablo Escobar's brother launched a coin recently, and he called it Diet Bitcoin. He's probably made millions off that because of the confusion in the market and the fact that somebody would have bought that. So we will use our license to inhibit, as much as we can, the possibility of that sort of diffusion of the network effect that we're trying to build. But that's not to say that anybody will need a license to build on Hedera itself. The Hedera platform will be fully open. No licensing fee to build on it. No special permission. You can build open source. You can build proprietary. Go to town. You don't need to talk to us. It'll be a public platform. There will be fees associated with building apps on top of it, but those aren't licensing fees. Those are usage fees. And another aspect of open source, or another key aspect of open source, is transparency. So while the code will not be copyable, it will be open review. So we fully support transparency. It'll be reviewed by third parties. Anybody can download it, validate that there's no malicious backdoors, compile it, compare it to the official. So one aspect of a public ledger that we don't confront in a permissioned ledger is the possibility of Sybil attacks, where anybody can spin up a node and thereby swamp consensus maliciously and skew consensus. So in a permission model, everybody knows who everybody is. We just don't confront that risk. In a permissionless public model, where everybody will ultimately be able to run a node, we have to mitigate that risk. So we do so with a stake model. Like other ledgers, they're recognizing the inefficiencies of proof of work and moving to a model where we eliminate or mitigate the risk of Sybil through stake, i.e. how many coins you have determines your influence towards consensus. So Ethereum's promised a roadmap towards proof of stake with Casper. EOS, Cardano have a delegated proof of stake model. So we're not alone in seeing the value of a stake model relative to proof of work. I will suggest that our stake model is relatively simple. So the votes that I described earlier that determine how Hashgraph works, or that are core to how Hashgraph works, in a public ledger, all the coins or all of our votes are simply weighted by how many coins we have relative to everybody else. So whereas in a permission model, one node gets one vote. In a permissionless model, in Hedera, the amount of votes you get logically is relative to how many coins you have relative to the community. So that's how we mitigate Sybil. Because if a malicious actor has 10 coins, they can spin up 1,000 nodes. But their relative influence stays 10 coins, because those 10 coins would necessarily be distributed across 1,000 nodes. So it's a good thing. We want nodes, but we want to dampen the influence of malicious actors. So that's how nodes stake towards consensus. And we hope and anticipate that eventually we'll have millions of nodes, right? The nature of Hashgraph, because it's efficient, it will allow you and I to run a node at home, high-powered PC with a GPU. This is no longer proof of work with dedicated mining rigs in Iceland. This is a consensus model that empowers everybody to be a node. So we want thousands and millions of nodes. But there are billions of people. And for whatever reason, some people will not be a node, whether impractical or they just choose not to. But they will have coins if we succeed. And we want those coins to be able to contribute towards consensus as well, because our security is benefited the more coins that are being staked. So if I have coins, but I'm not running a node, I can effectively lend my coins to a node. I proxy my stake to that node. They use that towards consensus. It helps with the security. And then the fee and payment model is such that we both are benefited. We both receive payment for the fact that we have staked and contributed towards consensus. So it's a fee model. So there's no inflation. We're not mining coins. We're not going to reward nodes by minting coins out of thin air. To use the platform, clients will submit transactions and pay fees accordingly. And there's a fee model that recognizes that the different nodes in the network may bear different burdens in processing a given transaction. So the fee model recognizes that. It's all designed to ensure that nobody is paid a fee until they perform the transaction for which they've been paid. So for instance, we can recognize that there is a long-term storage cost for storing a smart contract or storing a file on a node. Because the nature of distributed ledgers is if you're a node, you do everything everybody else does. You store the smart contract, you run the smart contract, you store the file, you store the wallet balance. We want to compensate those nodes for those costs, both in bandwidth processing and critically, storage. I think Ethereum is coming to this recognition. So there's a conversation in the Ethereum community and Vitalik of the importance of rent. Because currently their gas model doesn't adequately recognize these long-term storage costs. So they're coming to the same conclusion that you need to pay nodes for the work they do. Work in the loose sense, not the proof sense. And there's a treasury run by Hedera, run by those 39 council members, that will play a role in collecting and distributing those fees appropriately through a various set of payments and dividends. So sharding, those performance curves I showed earlier suggested that as the number of nodes grew, there was a degradation in the throughput we can achieve and the latency. That's physics, right? The more nodes there are in a network, the longer it takes for everybody to know about something happening. We confront that like everybody else. We arguably confront it more because we run closer to the limit than other ledgers. So there will become a time when, as we grow from the initial set of nodes, when we go live, like we're going to start with, say, 40 nodes, and the end goal is millions of nodes, there will come a time when we need to shard our community, our network, into smaller subsets. Just a representative of the sort of dApps that are announcing that they will build on Hedera. We're not yet live, so these necessarily are not live yet either. CU Ledger is that, I think I referred to a consortium of credit unions. So they've already bought Hashgraph for their permissioned use cases, but they have permissionless use cases where they need to deal with non-US banks, credit unions around the world. So they're going to build on the public Hedera. Satori is a very cool AI platform from Machine Zone with an associated coin. There are gaming platforms building on Hedera. There's an Uber equivalent building on Hedera. You know, early days yet, but a healthy ecosystem forming. So that's about it. You know, we think we're fast, fair, secure. Other ledgers are some of these. We think we're unique in the package. And remains to be seen how we do on the public ledger. But we'll be rolling that out towards the end of the year. Thank you very much.
Creating an open source version of this and offering it, and without anybody to sue, like, how are you gonna?
Yeah, so we're not naive, right? The patent, we expect the patent and the license will discourage credible businesses from choosing to build a non-authorized Hedera. More critically, we think it will discourage dApps from building on that non-authorized version of Hedera for the risk that would create. But inevitably, somebody will create and copy the ledger because the code will be out there necessarily for the open review. We anticipate that our network effect will be sufficient to ensure that ultimately we succeed where they don't.
Hi. I want to talk about the certainty over time that you were talking about earlier, and the difference between what you guys have versus traditional blockchain technology. So with blockchain technology right now, it's not uncommon for there to be discrepancies about transactions, and for those discrepancies to sometimes permeate over a number of blocks.
Right.
But invariably, you know, that gets reconciled after a certain period of time. Now, with your technology, there's not going to be any reconciliation after the fact. So, the way I see it, all it could potentially take is one mistake, like just one minor mistake for the network to potentially be compromised, and you can't go back.
So what would the nature of that mistake that a miner might make? Because the algorithm guarantees that we're all going to come to the same consensus timestamp for a given transaction.
Yeah.
The reconciliation you talk about in blockchain is, you described it almost as a feature, but it's a bug, right? You need to reconcile if there was two chains, one of which was temporarily portrayed and seen as the longest, but there was another chain that you needed to ultimately roll back to, right? The reconciliation that you describe is ultimately due to the fact that it's hard in blockchains to always be confident that you are working on the best chain, the truest chain. So sometimes you make a mistake and you need to roll back. We don't have that possibility because when we establish consensus, we're completely confident that everybody else has done the same or will do the same, and we can proceed. Now, that's not to say that the transactions themselves might be invalid. That will, of course, happen. But we can be perfectly confident that we agree on the order and the timing of the transactions. And then we just hand those up to the application layer for processing. So the application layer will definitely reconcile and reject certain transactions. But the consensus layer doesn't need to.
Okay. And typically, like you mentioned, this could happen in seconds, and it can be certain whether or not those transactions happen. Over time, I noticed that even when there was 128 nodes, which is, in my opinion, that's not, it's more decentralized than a lot of these consensus algorithms, but still not nearly decentralized. So if you were to have 10 or 10,000, 20,000, your latency would be, way up there, would it not?
Agreed, which is why when our network grows to the point, well, long before it would grow to that point, we would shard.
Okay.
So sharding is a means to ensure that latency does not scale exorbitantly as number of nodes scales. So we will shard when we start to see a degradation in latency.
Okay.
Sorry, question in the back?
More and more, it's becoming a cashless society with credit card processing and Interact. How do you see that evolving with the blockchain and Hedera technology? They're not going to let loose their golden goose. They're making so much money off of the processing right now.
So I think there's multiple questions there. So the question was, we already have a cashless society, debit cards, credit cards. Citizens, users are used to paying with a card and not having to deal with cash. I think the user experience will be identical in the future when people are paying with tokens or coins, ours or somebody else's. It'll be a seamless experience. It has to be. If it isn't, users won't adopt it. The only difference from the user's point of view, hopefully, is that the fees will be significantly lower, because no longer are we mediated by the banks. We can engage more directly and exchange coins and other value more directly. Your second point, I think, was a broader one about how do the banks stay relevant, I think, right? Because they have a business model that presumes that...
How will they keep their market share?
That's not our concern, right? I think.
Well, in a way, it is your problem as well, because you have to be forewarned or have a concept of how they are going to combat this new technology.
So banks are interested in this technology, not just ours, but more generally ledgers, for different reasons. The credit unions, financial organizations see value in a distributed mechanism by which they can do the transactions that they already do, but historically they've relied on somebody in the middle. Those transactions may not even touch the end user, right? Those are just settlement, processing, back office transactions. So financial organizations see value in ledgers for those use cases. I think they also, of course, are interested in Bitcoin and the example that Bitcoin and cryptocurrencies has presented. And I expect they are very interested in understanding how they might fit in those use cases as well. But again, that's their challenge, right? Because the nature of cryptocurrencies, by definition, empowers direct transfer of value, whether coins or something else.
Yeah, I think we are all wondering about the ICO details because there are all these rumors about the hard cap, and can you give us some information?
So the question is, can I share anything about the ICO hard cap token economics? No, no, and no. So the current plan is that there will not be an ICO in the traditional sense, traditional in the sense of the last year or two, right? And that's driven by the current SEC regulatory environment that the guidance is not clear, but it hints at platforms such as ours being very conservative, or guides us to being very conservative and cautious with respect to selling to the general public. So we're taking a more cautious approach than the historical ICO model.
Don't want to take this risk. And another question is about your competitors. A couple of days ago, the Phantom network, they released their virtual machine, and they have kind of similar technology, and I think they're going to be open source.
Yep.
Don't you think that the community, because that's why I think it's so popular, because people believe that decentralization, this is the main idea, right?
So agreed. So the question is multi-part. Phantom is another competitive protocol, relatively new, that argues characteristics similar to such as we promise. I would make the point, first of all, they claim BFT, but synchronous BFT as opposed to asynchronous. So there are technical distinctions. But to the broader point, they're open source, and therefore perhaps they will succeed where we don't. Everybody else is open source, right? So Phantom is not unique in that value proposition. That plot I showed, we unabashedly, unashamedly take that top left corner. And we recognize that for some in the community, that's incompatible with their vision of what crypto is meant to be, or the supposed ethos. That's fine. We are seeing enough adoption and enough interest to convince ourselves that there are others in the community that see the value of that top left corner, the stability that it will provide. It's a trade-off. We're okay with that trade-off. We recognize that some in the community that favor that ethos of full open source will reject us. That's fine. We're a choice. If they don't like the trade-offs that we present, they have lots of other choices. Phantom, EOS, Cardano, Definity, Ethereum, right? They'll look at us in the full picture, hopefully, right? If they reject us out of course, well, then they weren't our target audience anyway.
I have a few, so you ever want to come back? If you can't talk about how much or how many coins, how many Hedera?
Well, I think that's been made public, 50 billion.
Thank you. So when, is there any idea when?
So we have done an institutional round of a SAFT. There will follow a round for accredited investors. Testnet is ongoing, so we are starting to bring on partners and dApps working on the testnet. The plan for going live, mainnet, is towards the end of the year.
Okay, so for the average person, for retail type investors, I guess, I mean, if this is probably not going to be offered to those people, why should they be interested in Hedera versus something else?
So what I said was there will not be an ICO in the traditional sense. But that's not to say that individual investors will not ultimately have the opportunity, right? Our adoption, our success is predicated on the normal people having coins and using them to engage with the applications that are built on our platform. If normal people don't have the coins, then we will not have succeeded.
Right. So then that kind of leads me to another question about, I guess, second layer developers, DApp developers, whatever they are. And if say they have a legal agreement, I guess, with the council, would it be, or?
So there'd be no agreement, no licensing agreement. So anybody can build on Hedera. Just the nodes will be live. You can build your app, your dApp, and access them. You don't need to talk to the council if you don't choose to.
Sure. So I'm interested in who's on the council, and who gets to choose them, how's that done, and then what are the safeguards that they're not going to change the rules later?
Right. You did say you had a lot of questions. Which is no, that's a big one. That's a key one, right? And that's valid. So there will be 39. That is the current plan. 39 chosen because it's a number that divides by 3, and certain decisions will require 2/3 majority, so 26 of 39. The criteria for being a member is that you are a global brand with a reputable name, and so a desire to protect that brand. Geographically distributed across the globe, ultimately. Currently, we're well represented in the US, Asia, and Europe. We're, necessarily need to expand into Africa and India. The assumption is that any particular sector, be it banking or healthcare or consultants, 2 or 3 tops. We don't want to be overly loaded to any one industry. As to how they're chosen, necessarily, Swirlds, the company that has kicked this off and initiated this, has been very active in inviting and evangelizing to companies around the world the opportunity to be a member of this council. As the council grows, then those members themselves inevitably will form a membership committee, as any large corporation or standards body ever does. They form committees to continue to evolve. With respect to the big question, mechanisms to inhibit bad behavior, collusion, any sort of tampering, the easy response is to say, well, their brand is predicated upon the fact that they will act responsibly, as their current brand is, right? There's a competitive tension. The membership is constructed to discourage, if not eliminate, the possibility of cabals forming amongst these members. These are competitors, if not competitors from different regions. So the hope and expectation is that the motivation to collude will be minimized. Yeah. So I guess I would suggest that corporations such as these cooperate across a range of organizations and standards bodies and alliances, inevitably. And they are always doing so with the same possibility of price fixing or comparable bad behavior. And it's a combination of risk of reputation, legal consequences, and financial consequences that ultimately discourage them from doing so. And I don't think we'll be different. So we're not naive to the risk. We're trying to put in place mechanisms to inhibit that risk, term limits as an example. I would suggest or ask you to compare that model with its risks and its benefits to the alternative governance models that we're seeing in the public ledgers. Ones that are less rigorous, less mature, more ad hoc, and are those governance models appropriate to build the next internet on? We believe that you need something mature, run by companies with global brands and the associated expertise if we want to build what we want to build. So the question is there a version of Hashgraph that you could run in a permission model but still have a coin?
Yes. Yeah.
So if you want to build a permissioned network on Hashgraph, it is completely up to you how you monetize the interactions. It's going to be your own coin, right? Unrelated to the public coin. But if you wish to tokenize that, that's your call. Thank you very much.
Yeah.